Hi, this is Karen O'Brien, and we are going to talk about some LiDAR data and how to manipulate and get LiDAR data and how to turn it into data that we can use for Flow 2D using either GDS or the QGIS plugin. So let's start with a couple of the things that we need to get through this course or through this lesson. So we need LASTools. LASTools is a program. You can get it online from rapidlasso.com. Let's see if I can find out, see if I can remember who created this tool. Martin Eisenberg is the developer of this tool, and it is really awesome. Now there are plugins for both QGIS and ArcGIS that will also use some of these tools in LASTools, but I'm not going to do anything with ArcGIS other than show you some of their help files that kind of help identify and define LiDAR. I don't know how to use LAS data in QGIS or LiDAR data, in ArcGIS, so we're just going to skip that. So if you want to get this, you just go to LASTools and you just download it. Once you get that downloaded, I'm going to grab my download folder real quick. You'll see that it comes like this. Comes in lastools.zip, and then when you extract it, you get this guy right here, and you can just pop this guy straight into your C drive. That's kind of the default location of where you want this. I put mine on my D drive because my C drive is kind of doesn't quite have as much space. So I'll show you. Then once you get into QGIS, you can also get the LASTools plugin. So if you click Manage and Install Plugins, and you go to all, you can search LASTools. And you'll see that there's a couple of, if you just search the word LiDAR, there's a few different things that you can do with LiDAR, different LiDAR plugins, but I only know how to use LASTools. So I install it, it gives me version 1.4, and it gives you a bit of a change log, which is really nice. Okay, then if you look at my installed and delete everything, you can see that LASTools is right here. All right. If you want to do this, you also need the Flow 2D plugin. I'm using 10.26. So if you need 10.26, you're going to have to just reach out to me because it's probably not going to officially release it till the end of July. But people are already using it right now. So I'm going to close this because everything we need is already loaded. Now, if you didn't put LASTools on your C drive, then you need to come in here and you need to go to that. So that was, sorry, let me try that again. So you go to settings and then you go to options, and then down here on processing, you go to providers, LASTools, and then you can just double click inside here and it will bring up a browser so you can browse to the LASTools folder. And as you can see, I've already done that, so I'm just going to cancel out of that. Now we're kind of done with QGIS for a bit. Now let's talk a little bit more. So that's how you do, that's all you need to do to get ready to get LASTools going. Now let's talk a little bit about LiDAR. So what is a LAS data set? So that's kind of where we're at right now. These LASTools are going to work with a handful of LiDAR data sets, but mostly what you'll see with a LiDAR data set is a .las or a .laz. A .las or a .laz is just a zipped .las. And if you see anything other than that, like a .zlaz or something like that, you might not be able to use LASTools for that. Okay, that's a proprietary thing. So if you do see something like that, I just recommend doing a search on how to, utilize that data. It probably requires a specific program to utilize it. All right, what is LiDAR data? So LiDAR data is just light. Let's see, it's light intensity. I can't remember what it stands for, but you can look it up yourself. It's not really that big of a deal. It's not important that we know. Oh, here we go. Light detection and ranging. Yeah, light detection and ranging. So basically, you're going to get a sensor and a laser on a fixed or rotational wing aircraft. It could be a drone, an airplane, or a regular plane, and that's going to fly these straight lines across the ground, and then it's going to shoot the ground with the laser, you know, like millions and millions of times. And the paths that the laser is going to overlap on the paths, and so every time it does a swipe, it's going to kind of hit every point, you know, more than once possibly. Okay, so you can see here that you get your, you know, once you see your point, it might bounce back at a different, so you're gonna, let's just talk about the attributes of this data, sorry. So the attribute is the return strength, the return number for a specific spot, number of returns. The point classification is a post-processing, we're gonna get back to that in a minute. The edge of the flight line, the color that goes along with the aerial images that the camera is also taking, the time, the timestamp of the LiDAR, and the scan angle and the scan direction. And so those are all the attributes that come with the data. And then they are put into a file what's called a .las or .laz. And it's a binary file. So you can't just read a binary file, you know, you have to do some post-processing to get that data into a format that you can read. So the company that flies the data will process all of the data to identify the buildings, power lines, birds, trees, things like that. And then they will make categories or classifications of all that data. And that's what the point classification system is. So point classification is pretty simple. The ones that we're kind of interested in is 2 ground, obviously. And then we probably want to, well, we'll see in our data set what the difference is between 2 and 12 and 1. And so ones we might be interested in would be ground, building, road surface, and bridge decks. Those might be something that we would be interested in. And you can export this data by category, which is super cool because you can like export all your buildings or export all your roads and then utilize and then use that to help you define, you know, the stuff that Flow2D also uses, N values for roads, you know, vegetation density for land use, things like that. Let's go ahead and take one more thing. I guess that we're probably good. Yeah, it showed you that. And then we talked about that, so we're good there. All right, so now that we have now that we've kind of know what LiDAR is and we've kind of very rudimentary diagnosis of what LiDAR is, let's talk about how can you get LiDAR data. So for the most part, someone's going to be like, okay, here's your project, here's your data, and you're going to do the project. And the base data that they give you might be LiDAR. If you're in the United States and you're doing an urban flood study on a big city, you're probably going to have LiDAR data. Sometimes the entire county will have LiDAR data. Sometimes the entire state will have LiDAR data, but it's getting more and more common throughout the United States and in many places around the world too. Now, this LiDAR data is coming in this is Iowa. They did the entire state. So important things about Iowa or about this data set that you need to know. First off is that you can sort this data by watershed or county or city or whatever and download it. You don't ever want to download more than you need because it's ridiculously huge files. So the most important thing about getting this data is getting this tile. So this count them, but it's really not that important. But that's how many LiDAR data sets we have for the state of Iowa. And if you right click on this and you go to properties, you can see that you have coordinate system that this shapefile is. Okay, so it's got its EPSG code that we use in QGIS, NAD 83, UTM zone 15, and it's in meters. That's important. Oh, there's 36,999 of these tiles too. Cool. All right, so that's important to know, because that's going to make, because when you load that into your project, you want to make sure that your project is also set to that. And let's turn that off because we don't really need it right now. I also got the counties for Iowa, and I got, you know, some watershed boundaries and things like that. So let's go back to here and let's take a look at this Ashton Creek. And okay, sorry, I have to kind of reset this because I already did this. So let me try that again. I'm going to set it to watershed, and then I'm going to set that to Ashton Creek. And when I do that, it's going to update these results right here. Now, if you have data from some other system or some other server, it's not going to always be the exact same, but it's usually going to have some kind of data viewer that you're going to be able to identify your watershed or identify your region, and then, you know, break out an area by selecting an area and getting the data for that area. This one's a lot more rudimentary than that. It doesn't give you all those kind of cool, you know, selection by shapefile, selection by KML, etc. So it's not quite as good as like Earth Explorer on USGS. All right, let's go. But it's so easy to get the data. So as soon as you get the data, it's going to give you the list of the files that you can take. And again, we don't need all of these. That was just all the files for that one watershed. Now, the LAS files are not filtered by any means. They're just classified LAS data. Of course, they filter it and take out bad points by the post-processing system, but they're not filtered in any other way. And so, and then the ASCII data that they give you for this site is filtered. It is just filtered to category 2. All right, now, so let's see. Things you need for this data. So you do need to download and install the 7-zip decompression software, and you can get the link here. And if you have like more than 100 files, or you don't want to click on these individually, you can also use download them all, which is an add-on for Firefox and works really good. And I use this on lots of other things. So if you have something that you have to download a bunch of stuff from, this download them all is awesome because it gives you the opportunity just to kind of select all these files and then click download them all, and it'll just download what you selected. Now, I'm not going to do that right now because we don't need them all, because on the test that I'm going to do, I'm going to just use 4 of these. So I would take the 4 that I wanted from the list and then download them into, let's get to my project here, into this guy right here. And also, wait, this is definitely the wrong project folder. Sorry about that. I copied this over to the C drive for a reason, and we'll explain that later, but I need this on the C drive. It's important if you're going to be using the Flow2D QGIS Flow2D plugin processor with 4 LiDAR data, that you need your data, all of your data, to be on the C drive. Here we go. Here's my LAS data. And let's just sort this by type real quick. And these are the files that I extracted. So I only need 4 of them. And what I'll do now is show you the 4 that we're going to use by zooming in on the project domain. So I just created, first of all, let's get rid of the counties, and let's bring up the tiles. And you can see the names of the tiles right here. Those are the only files I need. So typically with a Flow2D project, you might have anywhere from 10 to 50 to 100 of these. And so you're going to be processing, things are going to take time to process, but good news is this LAS program is pretty fast. This LASTools really does this fast. So that's good for us. Now, let's see. So these are the 4 tiles we want. We can ignore all of the other data. You just want to get enough of these tiles to cover your project. Now, there's some other super cool things here that we can do. Like, obviously, we don't need all 4 of these tiles. So we can actually make some corrections when we process our data to minimize it to just this area. Now, remember this data was in UTM and meters. So, you know, in the United States, we don't really use UTM. We don't really use meters on flood studies. We kind of go for state plane. So I'm going to do some of the processing using UTM, and then I'm going to show you how to convert the data to state plane, and then we'll see it again on the state plane side. But a lot of these ways to use this data is just easier to start with the base data. Sometimes it's easier just to start with the base data and then convert it. And other times it might be easier just to convert the data. So we're going to try it both ways. And then that might require a second video because it's probably going to take too long. No problem. Now, let's talk a little bit about LASTools. So here is our project, and I should have one here somewhere that says bin, and I don't, but that's okay. We'll get right back to it. So I'm going to go to my D drive and LASTools and bin. Okay, so this is my LASTools program. As you can see, it's got a toolbox for QGIS and a toolbox for ArcGIS. It's got some example scripts that are really cool to show you how to set up like pipeline scripts that will do like a series of tools and process the data in different ways. And let's see. Oh, something important. So let's get in here real quick. Now, some of these tools are open source and you can use them without a license. And some of these tools require a license. So if the cost and pricing of LASTools is here. So if you need the Blast one, you can purchase it here using a PayPal link, and you'll see why you want to purchase it in a few minutes if we can get to the Blast to DEM part. If not, we'll have to do that in the next video. All right, so let's go ahead and just show you some of these. First of all, each one of these processors that we're going to use, these little, let's just call them components, will have a README file associated with it. And in the README file, not only does it tell you how to use the tool or a little bit of what the tool does, but it gives you some examples of how to use the tool. And it, let's see, and it gives you a list of the command lines arguments. So these are the arguments that you can pop into the command line. Now, there is a GUI. So if you use the GUI, oh, sorry, I don't know why that, okay, there. So if you use the GUI, I'm just gonna say right now that this GUI is kind of a pain in the neck. It's not a bad system. It's like it does a really good job of viewing the data and loading in the data, but what's really bad at is like every time you click on a close menu, it just closes the whole program down and it never remembers what you were looking at. So you'll probably get tired of the GUI right away, and instead you'll want to do things from the batch script instead. So we're going to try to show you how to do all that like in this class too. So let's start with QGIS and doing the processing from QGIS. So you can use the LASTools and use the LASTool GUI, and that's fine. It's actually a really good way to do things once you're starting to learn LASTools. Or you can use the LASTools from the GUI by using the processor toolbox. So that's this guy right here. So if you can't see this guy right here, go to the plugin menu and make sure that it's installed and checked. And then once you're in here, well, you see that the LASTools are all right here. But once you're in here, just search the one you want to do. So the first one we want to do is LAS2Text. Well, let's see if we can do LAS to DEM. LAS to DEM. Let's just see what LAS to DEM does. Well, we need text data. So I'm not super duper duper concerned about, yeah, let's do LAS to text. Let's stick with the program here, LAS to TXT. I hate when I shift gears and totally change my method right in the middle of a class and then something doesn't work. So let's not do that. All right, so run the new 64-bit executable. That's what we'll choose here. I don't know what verbose means. It's something to do with the way the script is written. So I'm just gonna leave that unchecked because I don't really know how to use it. Now, here's the input file that we want. Let's just take, let's see, which one do we want? Oh, okay, let's do one cool thing about this processor is that you can still get in here and see things. So I think we are going to take the 027844704 because it has some features I want to show you. Okay, so I said 027844704, and we are going to convert that to text. So I want to delete that file right there. And parse string, let's go ahead and go with XYZ. Obviously, that's what we want, but let's go ahead and add intensity and class here. And line parameters, no, don't want anything there. Now let's save that to the output file, and we will just choose this guy, 704, but take that off and call it txt. So this is just processing one individual file so that we can just review and look at the file. Gonna go ahead and click run on that and wait for it to complete. And it says results none. Hang on a sec, why does it say results none? No, that's perfectly fine. I think it's because it didn't load any layers would be my guess. It is not gonna load the data for you. It's just going to create it for you. All right, now, I opened this over here on the other window, txt. This is the file that we just created, and I'm going to open it here. And so you can see that it's space delimited data, X coordinate, Y coordinate, Z elevation. Now remember, this is UTM and this is meters. This is the intensity field that I was telling you about, the strength of the returning light signal, and I don't really know what the range of data is, so I'll just ignore anything about that. And this is the classification. Remember, ground was 2 and 12 was, I can't remember what 12 was, but we only have like 1s, 2s, and 12s in here. So I'm going to show you what this data looks like in a minute, and we got let's see, is that 2,034,121 lines of data points. So let's import that into QGIS and just take a look at it. So if you use this guy right here, you can import text data into QGIS. Now, I do not recommend that you import all of your text data into QGIS because it's a ridiculous amount of data. And I mean, maybe if you indexed it or something like that, but it's just, you don't need it. But I want to show it to you because just to see what the difference is between the data with the categories and the data like that has filtered by category. So I've already set this up. Once you point to your file, it is a custom delimiter, space delimited, no headers, no field names, yes, detect field types, yes, trim fields, yes, discard empties. Field 1 was X, field 2 was Y, field 3 was Z, although I don't really know why we need that. I just picked it because it was available. And click add. And that should be, okay, now that's done. And now I'm gonna go and close it. And I'm gonna go back here to this LAS to text. I'm gonna do the same thing I just did, except this time, see, that was 784, 70. And this time I am going to add a command. Let's see, just so that the data is exactly the same. I'm going to add a command to filter or to keep only the class of ground. And then I'm going to save this to file, but this time I'm going to change the name slightly to ground. Yeah, that works. And run, and we'll wait for that to complete. It shouldn't take but a second because there's actually exporting less data. And that one is done, so we can now close it. Now, let's do the exact same thing and load this data, except I want this one to be on top. So I'm going to put my cursor right here and click the project domain layer. I'm going to add this by grabbing it, and everything should be the same. So X, Y, Z, and I don't think I need to change everything else. Just click add and close. Okay, now let's see which one has the most data. This one has the most data right here. So I'm going to double click this to set up the symbology, and let's do, sorry about that, that thing keeps clicking. Let's do, see, we need to change this to no pen, and let's 0.5, and then change the symbol to graduated, field 3, color can be spectral, and classify, and then we'll just color this data a little bit so that we can kind of get an idea of what the elevation looks like from the points. And I'll click apply and okay. No, actually, let's see. Yeah, let's click apply and okay. And then I'm going to copy this data here. I'm going to copy this style, and I am going to paste it to this style. Okay, so now I want you to just notice what the difference is between these two data sets. So the full data set has some strange things in it, right? Like what's going on over here? Why is that not completely flat? Why are those bright blue? And why do we have bright blue things over here? Well, it's because there are trees and stuff in here. Now, the trees are, let's see if we can zoom in on one and figure out what these trees are. That should get us there. Now I'm going to hit the ID tool. I don't know if this is going to work very good or not, but I'm going to try it. I'm going to hit the ID tool on this guy right here. Make sure you're on the active layer and then click it. And I want to see what the category for tree is. Okay, the category for tree is 1 in that case. And then the category, okay, then you see here we also have, let me zoom back out, and let's go over here to where we have some buildings. Whoops, I might have messed that up. Nope, I'm good. Well, let's just wait for it to, yeah, it's down here. Okay, and let's grab the categories of these buildings. And the building category is, oh, well, you know what? I probably messed that up. The building category is, I only needed 1 of those, so also 1. So it looks to me that anything that's not ground or overlapped, I think 12 was overlap, ground or overlap is just categorized as 1. Okay, now check it out. When we take off that, you can see that it filtered it out, and it only gave us, and it took the buildings out, and it took the trees out. And so this data will just be filled in from its neighbors when it gets interpolated to the grid. It'll just be like nearest neighbor type of thing. Okay, so that's how LiDAR data works. Now, if you had some kind of cool tool like Global Mapper or ArcGIS, you would be able to get down in and see like power lines and birds and, you know, curb and gut. You could align and assign curb and gutter. So we're not getting that cool with this data. It's not that robust, but we don't really need all that anyway. So we're just going to use it for what we need it for. So I'm going to go ahead and turn these off, and I'm going to remove them because, like I said, we don't need this data in here. So I'm going to remove the layer. And the next thing we're going to do is let's get rid of this identify results, a batch of the same thing we were just doing. Okay, so check this out. If you hit the LASTools tool and you come here and you hit the run as a batch processor, this model, that's what this is. It's a model that runs like a series of tasks, you know, like finding your files, setting up all the parameters, and then executing each file individually. Works pretty good, and it's pretty sweet. So now here's the deal though. You can either start filling all these in automatically and then save it once you've got them all filled in. So I've already done that, so I'm just going to grab this guy here, and I am going to open the LASTools JSON file, because I already saved that from the last time I did this. So the cool thing is that it fills everything out for me because I'm done with it. All right, check now. So I don't remember. I don't know what verbose is. I did a little bit of research on it, but I didn't really need to know what it was, so I just ignored it. Yes, on the run, the 64-bit filter. Now let's see if now normally these are all default no. So I can change the first one and then autofill down to change the next one, or I can autofill from an expression, which is pretty cool. Not so much for this one, but for other ones. Do not use the LAS GUI with this. It's just a pain and it doesn't seem to work very good. I don't know, it didn't work for me, so maybe it was just me. And then input files, these you kind of have to get individually. Or you can kind of copy them. Like one of the ways to copy a path is to shift right click and copy as a path. And then you can just pop that in here, or you can use this guy and just grab it like that. And this is your input data, so we want that to be input. Parse data, this time we only want XYZ because I don't need all that data. And this time, I'm going to, hang on a sec, let me get this over here so I can make it a little bit bigger. I'm going to add an additional command line parameter from the list of from the README file list. So if you don't remember, this is the LAS2text. So LAS2text is LAS2TEXT. The LAS2text README is here. And I'm going to grab some of these extra commands, these additional commands, so you can filter based on the coordinates. And that's one I want, is the filter is to keep the X and Y within this box, within this bounding box. I also want to filter by class. So I want to keep class 2. And that'll be this guy right here, keep class 2. Okay, so I have added these commands into this, everything is space delimited, and I've added these commands in here. Let's take a quick look on this and how I developed this, just to show you. So I'm going to grab a blank notepad, and I'm going to just put this in here because it's a little bit easier to read. So very simple, keep _XY, and then this is, let's see, we got to get, I think it's X min, Y min, X max, Y max. And let me get a quick, let me just confirm that. I'm sure it's fine, but okay, so let's go back up here to keep XY. Yeah, X min, Y min, and X max, Y max, and like you can see, it's space delimited. All right, so let me show you how I get this super easy with QGIS to get these coordinates, and I highly recommend this. Okay, so if you come to QGIS and let's just get this thing out of the way for now, because we're going to do all our work in that notepad file for just a minute. All right, so if you come to QGIS and you're on your map, I don't know, I always kind of pick up this guy, and I just come down here and make sure that I'm kind of outside the boundary of that project domain, right click, and I can copy the coordinate. Now I'm going to go back here to this guy, and I'm going to hit enter, and I'm going to paste my coordinate, and then I'm just going to clean it up a bit. Okay. Let's see, so 3, we can just do that, and this one would be like, I don't know, like 9590. It doesn't matter. This is the minimum data, so it can be 90. So for the maximum data, you want to like maybe raise that up to a ceiling, and the minimum data, drop it down to the floor. And that just makes the data a little bit easier to read. Same thing to get the max. You just put your cursor up here and make sure that you're, slightly past the boundary, right click, copy coordinate, and go back to your text file, paste that in there, and same thing. So now this one is, we're going up to the ceiling, so that's 60. It's not really that important. I just hate coordinates with, and then this one would be like 50. And then, of course, that's in meters. And then you can copy that and put that in here inside the command window, and take the entire command, make sure that there's only one spaces, make sure there's only one space. I don't know that it's important, but I'm pretty sure it strips the spaces out. It strips and splits the data when it reads it, so I don't think it matters how many spaces there are because of that strip and split function that the data parsing does. So you can copy that, and you can come back here into this command line and paste it in here. And then again, just fill down, because it's going to be the same for every one. Output data is also easy. So basically for the output data, I'm just taking this, copy, and then I do this. And I can output to paste, and then TXT, and then save that. So I already did all that, so I'm just going to check them real quick to make sure that they're the right ones. 704, 84706, 804704, 804706. So these are all good. And then when you click run, it's just going to run these in batch, as a batch process individually, and then save them. So first thing we need to do is come over here and delete all of these, and that should be good. And then we want to play that or run that. And then over here, you should start to see these guys filling in. So you can see those filling in, so you know that they're getting processed. And then over here, it'll tell you, like, when it's done, it'll tell you that the execution was complete and how long it took. So the cool thing about this is, like, if it's a lot of data, you'll get to see the progress bar and you can track it. That's pretty sweet. Now, but what we want is this log. Okay, so what we want is this guy right here, the LASTools command line, right? Just want, yeah, this guy right here, copy, and then I'm going to pop that into a text file, because I can then come back and replace some of this data, and then I can run this as a BAT, a Windows batch program. So I'm going to grab this here. Let's see, I should already have one in here. Sorry, I'm in the wrong spot. Give me a second here. So this is the las2text.bat. I'm going to open that in Notepad, and let's do that. And you can see here that I have the location of the batch file, or the location of the program, and then the other information. And then we can just replace this with like a path, a list of projects. But we're not going to do that yet. That'll come later. So there's 3 ways to process this data. One is through QGIS, one is through the GUI, and one is through the batch files. So that's what we're going to work on here. Okay, let's now, but for now, I just want to get the data ready for Flow 2D, so I don't care about all that extra stuff just yet, because my idea is to get this ready to interpolate to the grid, and this is what I need to interpolate it to the grid. Now, if you wanted to load these back into your map, what you would hopefully see, and I'm going to do one just so we can see what that filter did for us. Okay, so let's see this guy. Yeah, there we go. And let's grab this one, and I don't think we need it. Just 1, 2, add, and close. And you can see that it didn't give us the whole tile. It just gave us the data that we needed. So it's going to go way faster, so we don't have nearly as many data files. Okay, so I'm just going to remove that. And okay, let's go with the Flow 2D tools. Okay, now let me zoom to the project domain. So you need a grid. So I think I have a grid, but I'm going to do it anyway. So here's the deal. I'm going to show you a couple things because there was a bug in this version of the plugin. So if you create grid and you use an external polygon, and we're going to go PR for project domain, I just typed PR in there. It took me right to the layer I wanted. And the field is called cell size. That's your grid element, the side of your grid element size, okay? And then if you have like your elevation data is in a raster, you can align it to this raster. And I'm going to click OK. And it's going to tell me that there's a grid already saved in the database. Do you want to overwrite it? And I click yes. Now, I don't know what my cell size was in that project domain, but it might give me like a few too many cells, which is okay. I think my original, or my 10 meter grid size gives me about 44,000 cells, and I'm not sure what the cell size is here. Well, it's taken a while, so I'm assuming it's 3 meter cell size. That's okay. Maybe I'll pause it, and then when it's done, it'll tell us how much time it took. Okay, so yes, the cell size was 3 meters, and that gave us 494,000 cells, and it took 1 minute and 11 seconds to complete. Now, again, if you click this button and you try to calculate something and it tells you that there's no computational domain, you have that bug that I was talking about. So you need an update to the plugin. I've already fixed it and I've already merged the code. So just get with me and get the bug fix, or just put your project domain, copy your project domain to the computational domain layer like we used to do before I had this alternate system. Now we're finished with this guy. Let's see, what do we got here? Where is this dude? Zoom to layer. Weird. Oh, God, good grief. Sometimes I wonder about my brain. Okay, move those to the bottom. We don't want those to be covered up. All right, so now let's go ahead and zoom in, and you can see these are 1 meter by 1 meter grids, and you can see we have, let me grab this ID tool right here, and if I click on any one of these, you can see that we now have 494,000 cells. Now let's grab this new interpolation method, and it is this guy right here. There's actually 2 new interpolation buttons, but I'm only going to show you this one. and it is interpolation from LiDAR files. Now, the first thing it's going to have to do is create the rows and cells of the data. So I'm going to click OK and let it start doing that. Now it is calculating the rows and cells of the data so that it can set up a NumPy interpolator and interpolate the points by just a standard average. It's not a distance weighted average. Now the rows and numbers were already assigned, and so now it opens up so that you can select all of the files that need to be written to code. Now this is important. If your data is on your C drive and your project is on your D drive, this process is just going to take forever. So make sure all of your data, your geo package, your QGZ, everything is on your C drive before you do this. And I'm going to click open and it's going to start. Now you can see that it's reading the data right here. And now it's updating the elevations. So the interpolation is basically done. And the kind of the thing that takes a long time is like getting the data back into the geo package. And so this is going to take about a minute or two, but I'm going to pause the video and we'll come back because it'll give us, it should tell us how much time it took once it's finished. Okay, so this is still processing. So while it's processing, just since I'm not sure how long it's going to take, let's do one more thing. And I will minimize QGIS. We're done with this. And now let's talk about converting the data between LAS UTM to LAS or to state plane. Okay, so let me grab this. Now I'll do this one from the LAS GUI because my QGIS is being utilized by something else and I don't want to, I can't, it's locked down by like that. I could open another QGIS and do it that way, but you've already seen the process through LAS. So let's take a look at this one through the LAS executable. So this one, to convert the units, you want to do LAS to LAS and just open this up all the way because you're going to need everything in here. Let's see what we get here. So we need to start by adding the data. And if I do this, and so be careful the first couple of times you use this, it might be kind of annoying because it doesn't, like the browsers and things like that are not that great. So C:\projects C, and I click go, and then that takes me to my C drive, my project folder for my C drive, and here's my project, and here's my LAS. Yeah, it's kind of like the RAS one, you know, it kind of sucks navigating to things. Like, I don't know why they can't just give you a little open button so you can go navigate using Windows and then it just fills it, but they didn't. Now we're going to use these four here. So let's just click add and it will add all of these. And there you go. You can see that we have them all right there. And I want to make sure and delete the ones in here because I want to overwrite them. And I'll move that back out of the way. And then we will, let's see, we don't need to filter anything because I can just not worry so much about the filter. Okay, but I do need to set the projection. So my projection I know is UTM, I know it's zone 15, and it's the northern hemisphere. The datum is NAD 83. Let's see, NAD 83, that's this guy right here. Oh, and let me show you how I get all this information. I mean, you probably saw this already when I loaded that tiles shapefile, but I forgot to show you this other stuff on here. So if you don't know the metadata of your project, you can come here and you can click metadata and it will give you the quality information, spatial reference. That's kind of all I use out of here. So the data quality talks about how the data was how they did the quality control on the data. And it gives you the vertical accuracy, which is plus or minus 18 centimeters. And it gives you the horizontal accuracy, which is 1 meter. It also gives you the spatial reference info. And so our horizontal coordinate system is UTM zone 15 north. And our, let's see, do we need anything else out of here? And our horizontal datum is NAD 83. And our vertical datum is NAVD 88. And the units in both are meters. So that's what we need for our conversion program. We are not going to convert a vertical datum. We are just going to convert the horizontal datum, and we're going to convert from units of meters to feet. Okay, so we got our UTM zone 15 northern hemisphere, NAD 83, elevation is meters, vertical datum is NAVD 88. I think the GOID was, I don't know if that's the vertical GOID. It didn't really say, so I was just leaving that blank. The horizontal GOID was 80, but I didn't see one for this one. So I'm just going to leave that blank. And it seems like it's fine. It seems like it's working fine. And I don't need any of this other stuff. Keep this thing as simple as you can. Output data. Okay, now for the output data, we need to change the directory. So again, this is like the worst part of this, but it's okay. It doesn't, once you get used to it, it's fine. C:\projects C, and then you hit change, and then you can grab that. And we are going to pop that into this folder. Hopefully this will work. And click use current. And then if you put your cursor in here, you can see that everything, that path is cool. And then target projection is state plane, Iowa. So just don't bother with your cursor, it doesn't work. Just try to find the eyes. Let's see. Or maybe it does work. Let's see. I. Oh yeah, it does. Nice. So it took me to stupid Idaho instead of Iowa. I need IA. Yeah, I don't know why, but it does not like to go to Iowa right away. Oh, shoot, that's funny. Illinois, Indiana, Iowa. Here we go. Iowa North. And okay, Northern Hemisphere, the unit, we want this unit to be feet, and we want the elevation to be feet. And I don't know what to do with precision, so, oh, I know what it is. It gives you like that. So I'm just gonna leave that default and see what it gives us. And then the output format is LAS. And we're gonna run this in 64-bit. So this is the key. Don't hit quit or don't hit close on any of these buttons because it'll close the whole program. You got to start over. So do hit run 64. And cool thing is here is that you can see that it's all here. So again, I'm going to copy that. And now this is the LAS to LAS. So once I copy that, I can go back here and I can grab this dude, LAS to LAS, and I can open that in Notepad and paste that in there and kind of doctor it up a bit to make it look correct. And then we can for the next one, we'll show you how to use those. And then just click start. Well, let me get back here and open our state plane first and click start. And then what we should see is this dude should start to fill up. Horizontal datum source unspecified, assuming save as target. I don't know why it says that, but it seems to work. So I'm just gonna like ignore it. Now, it did not put that in my folder for whatever reason, it did not like the fact that I chose, yeah, this is so annoying. I don't know why, but this thing just does not work that good. I'm gonna try it one more time. I think it's in the bin folder right now. And if you looked in your bin folder, you'd probably see that they're there. Last two. Nope, they're not in the bin folder. That's good. And they are, maybe they're here. Yeah, it put them in here instead. Okay, so I'm just gonna grab these dudes and I'm gonna and I'm gonna cut them to this state plane folder. And let's do this real quick. So I'm done here, close this, and now I can close this. And let's check our QGIS real quick and see that's still going. So let's just let that do its thing. It's probably gonna take like 20 minutes. And then while we're waiting, let's go ahead and open a clean QGIS and we'll put it to the new coordinate system and then we'll load the data. Actually, we'll probably have to load the data as a text or a DEM or something like that. So yeah, we can do the DEM conversion and then load the data. So this is the LiDAR project with the state plane coordinates. So let's try this guy. And I'm going to just remove these. I had messed up this webinar and I had both my geo packages were on my D drive, but my data was on my C drive. And so I kind of messed everything up for me. Okay, now let's use, so that's why I had that message to remove all the layers, because otherwise you would see them twice. All right, let's grab this guy here and let's just we're gonna do last to DEM and we are going to fill this in for just one file like we did before. Okay, and let's just grab this one and we don't, yeah, let's do keep class 2. And the pixel size will just say one. Actually, maybe you should put that to like 3 since we are. And elevation is the attribute, actual values. And I'm gonna just not worry so much about any of these guys. And yes, I want to save to file. And let's just grab that name. .tiff. And click OK. And click run. Now, I don't think this is going to add that TIFF to the map. It did not. But what it did do is it gave us a KML, a TIFF file, and a world file. So we're just going to drag this guy over here. And oh my goodness. I don't know what this is, like why it does. Oh, look, I left that at default and it gave me a bunch of these. I'm not sure why this doesn't show up for me. I had the same problem a few days ago. Like I put this into the map and you can see the data's there and you can see that there's nothing wrong with it. Like you can see that it's in the right range and everything. And if you hit ID and you click on it, let's see, zoom to layer. So if I go right in the middle, it says no features found. I bet you, I wonder if it has something to do with the fact that my world file is not being loaded with it. Like it's not identifying the world file. Let's try this. Now, if I did it from the GUI, then it will load. Okay, let's try this. Maybe it'll recognize the world file. I have no idea what this is for. I bet you it's lost. Let's do this. Let's try this. Oh, look. No, dang it, sorry. Yeah, there we go. Okay, yeah, that was what it was. It projected it in the right coordinate system, but it didn't, but I think because, I'm not sure what happened, but it looks good now. And so you can do that for all of your rasters, or you can do that as a batch processing. And if you did it as batch processing, you could merge them all into one. But if you do that, the BLAST is not a free tool. So it's not, your data is not going to be perfect. It's going to have vertical lines going through it. So you won't be able to use it to analyze your elevation because it has vertical lines that have a 0 elevation in there, or maybe even like a negative 9999 elevation or something like that. So it's no data. So you have to purchase the tool in order to get this to process correctly. But you can see that it's loading in the right spot. So the coordinate conversion worked. Once we, assigned the correct system to it, it works just fine. Now, so you can use both of those tools. And I'm not sure what the KML gives you, but I guess, oh, great, excellent. Okay, so that took 15 minutes to process the points. There were 1 million points inside the grid and 355,000 outside the grid, and it took 15 minutes. Now I'm going to click OK, and I'm going to, anything that has a 7,000 points were not interpolated, 7,000 cells, because they were buildings or something missing. So I'm going to interpolate those from the nearest grid elements and click OK. And that shouldn't take very long. That usually goes really fast. So once that's done, then you are going to want to QC your data and cancel. And I do not recommend that you QC your data from the grid layer. Instead, let's see, I'm not sure what's going to happen here. Let's see what happens here. Yeah, nothing there. If you had some negative 999 data and you use this render elevation checkbox, it would probably show you that negative 999 data. Instead, we're going to go properties. Let's make this I'm going to change this from simple outline to simple fill. And we are going to choose a fill color. Let's see, sorry, we don't want an outline. And then we're going to set this to graduated. And we will go spectral and set this to elevation, and then classify that. And then let's see, yeah, we do have some 0 elevations. We don't want any 0 elevations. Let's see where they are. I'm going to click apply. Oh, what the crap? I have like, oh no, wait, never mind. Let's see. Let's try this. Uh-oh. No, it's okay. This is okay. This is the metric map. The other map, when you do this, the other map will be state plane and it will be feet. So let me put this up to like, I wonder what the lowest value is. 3, let's say like 389, and then click apply. Oh, fascinating. Let's, And let's also invert the color ramp and apply. And then let's just see if we have some values in here that are zeros. Let's see what we got. Let's use the Flow 2D ID tool. Oops, I need to close that window. Yeah, there's definitely, they aren't zeros. But if there's a 0 in here, we don't want to see that. Let's do this. Let's see. I want to filter elevation equals 0 and click OK. And then, yeah, we do have some. Okay, so yeah, there's some zeros in here where it didn't interpolate from the neighbor correctly. So, or maybe, I don't know, maybe why, I don't know why there would be zeros in here, but we should be able to interpolate those or fix those with this this tool right here. But you shouldn't see those, so that's something that we need to fix probably on our end. And it looks like there might also be some zeros on the edges here where there might be some missing data because I might have snapped my data wrong. I might have put my cursor wrong when I exported my data. Like I might not have put my X max up high enough. I was probably like right in here and I needed to be like right in here. So that's my fault. And these things in here might be our development fault. Okay. Okay, so, but it worked, so that was good. Now let's let's see. What was I doing over here? Okay, I'm gonna stop the recording right now, and then we'll return next week to show how to use the batch processors.